So a very warm welcome to each of you, and it's wonderful that you are joining us this afternoon for this webinar. I kindly request that you can introduce yourself on the chat box as we continue waiting for the rest of us to come in. Thank you. And we are about to start we are expecting to start at 2 or 5 p.m. So kindly, as you join in, you can introduce yourself on the chat box. Thank you and welcome. Remember, this is an interactive session, so feel free to use the chat box. And once we start, you can also use the Q&A so that you can present your questions. And remember, all the presentations will be shared with you at the end of the webinar. And I will also kindly request that all our speakers, while presenting, they will also put on their view so that we can also see where they are from, or we can see their faces as well. Thank you so much. Thank you so much for those who are joining in. Thank you so much. I can see people from Ethiopia, from Somalia, from Sudan, from Kenya as well. Thank you so much. As you join in, kindly just introduce yourself using the chat box as well. I think it's now time to begin this webinar today. Once again, thank you so much for joining us from wherever you are. We really appreciate setting your time so that you can be able to join us in this webinar. For those who are just joining us, I'm Linda Akoth from C5M Boy, Taita Taveta County, Kenya, and I'm so excited to be here. I'm ready to learn and to experience so much with you today in this webinar as we discuss on early warning for mitigation of climate risk. Today, we will be looking into satellite-based early warning for food security monitoring in Eastern Africa. For all of us who are in this webinar today, we have all witnessed the challenges facing regional agricultural production systems due to extreme weather conditions and climate change. And it's for this reason that we have now a renewed focus on developing early warning systems for real-time monitoring of crops and rangelands. Such systems are vital in detecting short-term deficits in crop production, resulting from a range of drivers, especially in areas that are frequently impacted by high cases of food insecurity, for example, East Africa. The East Africa Agriculture Watch, that is known as EAAW, is a public online decision support system that helps in monitoring crop and rangeland conditions in near real time. This system is based on the Global Anomaly Hotspots of Agricultural Production, known as ASAP platform, that is developed by the Joint Research Center, JRC, of the European Commission. So the major objective of this webinar today is to inform GHACOF 68 participants on use of the East Africa Agriculture Watch for agricultural monitoring activities, looking at early warning and response planning, anticipation at regional, national, and even to the sub-national level. Specific objectives of the workshop is, first of all, to introduce GHACOF stakeholders to the East Africa Agriculture Watch, and also to create an understanding of the products and the processes of the East Africa Agriculture Watch. We also hope to demonstrate the use of the EAAW to monitor current season and access the previous ones. And the most important of all is also to collect feedback from experts on the system. So with this webinar today, we hope to achieve an improved understanding of the East Africa Agriculture Watch as an early warning tool for early action. So as you can see, we really do have an exciting agenda that is timely, considering the fact that we have witnessed so many negative impacts as a result of climate change and also extreme weather conditions. So it's a timely event, a timely event for all of the world. So your participation is crucial at this moment. Do not hesitate to share your thoughts and engage with our speakers and also fellow participants. We have two panelists today, and to take this opportunity to introduce them before they can do their presentations. First, we have Dr. Felix Rembold. Dr. Felix Rembold is the Food Security Team Leader at the Joint Research Center of the European Commission. He has a strong academic background in tropical agriculture and extensive research experience in utilizing Earth observations for agricultural monitoring and food security early warning. We are so glad to have you with us today, Dr. Felix Remold, and look forward to hear more from you. The second panelist is Oliver Kipkogei. Oliver Kipkogei works as a regional agrometeorologist at the EAAW Climate and Application Center, EAAW, Nairobi, Kenya. He holds both a master's and bachelor degree in meteorology from University of Nairobi, and is currently pursuing PhD at the institution, focusing on climate risk management in agriculture and food security. So we are really glad to have you with Oliver Kipkogei, and we look forward to hearing from you and learning more from your presentation. So without further ado, let's kick off them and make it a memorable and enriching experience for everyone. So thank you so much for being here. And at this moment, I would like to invite Oliver Kipkogei to share its presentation. And remember, as I earlier said, that all the presentations will be shared with you, all the participants, at the end of this event. Thank you so much and welcome, Oliver.
Thank you very much, moderator, and a warm welcome to this presentation. As the moderator, I think he has given in our background, we are going to do a joint presentation, and the presentation is going to be about the East Africa Agriculture Watch, which is actually one of the early warning systems that we have in our Eastern Africa region, responding to some of the challenges and issues that we have in the region. So just to give a regional overview. So we all know that approximately 70% of the region is highly dependent on rain-fed agriculture, and this practice is also contributing significantly to the economy of the region. And also another fact which is increasing vulnerabilities in the region is the fact that a significant percentage of the region is classified as ASAL, arid and semi-arid. And we all know also that climate variability and change are one of the main drivers of food crisis. Of course, there are other drivers like conflict, macroeconomic issues, but we all know that climatic extremes in the region is one of the leading drivers of food crisis. Also, if you look at the issues to do with climate change projections, there is a high frequency and intensity of these extreme events happening, including the droughts, the frequency of droughts, and also floods, among others. So as a result of all this context, there is a need for continuous monitoring, and also monitoring and forecasting, but this focuses on monitoring of agricultural conditions across seasons. And this system serves 11 Eastern Africa countries, which is EAAW countries. So we have 8 IGAD countries, and including Burundi, Rwanda, and Tanzania, which we call them EAAW countries, which are also part of EAAW countries. So just to give an introduction of the EAAW system. So as I think the moderator has done a good job here, but EAAW stands for Anomaly Hotspot for Agricultural Production. So it's an online decision support system, mainly for early warning about agricultural production anomalies, based on a set of global satellite and agrometeorological data. And also, so in our next, I think my colleague will talk about the criteria and the threshold for highlighting these anomalies. And it is one of the bases for EAAW and also JRC contribution to GeoGLAM. So JRC contributes globally, but also EAAW contributes for the Eastern Africa for the GeoGLAM crop monitor for early warning. So the system mainly ASAP aims at making available timely and improved evidence for informing food security and humanitarian aid policies. As you can see from what we have in the diagram, we have the ASAP system, and it contributes to global initiatives that we have, like, for example, the Global Report on Food Crisis, the Food Security and Nutrition in the World reports. There is the issues of IPC, the armies. But aside from that, it also contributes to in Eastern Africa, it contributes to the state of climate, annual state of climate that EAAW normally produces annually, and also contributes to the initiative at the region, which is the GHACOF. It contributes to impact reporting in the GHACOF at the national level and sub-national level, as you can see from the other. So this is a system that is playing a critical role in the region. Just to give a short introduction of the system. So system, first of all, has the Warning Explorer. And in the Warning Explorer, you can have a multi-scale kind of analysis, whereby you have, like for the case of Kenya, there are 2 levels of analysis. You have at provincial level, the old provincial level and county. In the case of Uganda, Ethiopia, for example, you have the state. You can have statistics at the state level or at the Warrender level. So there is the cost kind of analysis that you can get, and also the high resolution. And this is mainly targeting based on the user need, and it's targeting multiple user groups. Then there is the country assessments page, where every month there is a number. We have analysts, system analysts, who normally give like an analysis of each country every month. Like for the case of Eastern Africa, you analyze based on the information indicators that you have. You give an analysis of, and this is actually, it's meant for the non-technical people, so they can, in a nutshell, they can just see what is happening in a country. And then there is the high resolution viewer, where you can now zoom to the field level and actually make an assessment of what's happening. So this is some of the, actually the last 2 are some of the things that we used to aid country assessments. So we have regional implementation of this ASAP system. So in Eastern Africa, we call this, it is implemented by EAAW under CLIMSA project, Climate Services and Related Application, and it's stamped as the Eastern Africa Agriculture Watch. Also in Northern Africa, there is a version of the ASAP, and also in the Sahara. So for the Eastern Africa Agriculture Watch, you can derive 3 sets of information. There is automatic agricultural drought warnings that you can derive, that is given every 10 days automatically based on, so you mainly look at the WSI indicators. You look at WSI, SPI, and also vegetation. So we get such kind of warnings every 10 days, showing areas that has anomalies, production anomalies. And then there is now zooming to, be it maybe level 1 or level 2. You can zoom to, let's say the case of Ethiopia, you can zoom to a Warrender level and get statistics of those anomalies, including even the progress of the season. You can get indicators like rainfall, temperature, and the percentage, the number of the area that is affected by such indicators. And then now there is the high resolution viewer that can actually take you to the field level, where you can make some assessment on what is actually happening. I think this will be shown better in the demonstration section. And just to say that we have 2 admins, as I said. There is the course resolution, which is a bit higher, and then there is the admin 2 that can be used at really lower levels. And so in the process of deriving these automatic warnings, there are steps that are followed. The first step is actually detecting active crop or rangeland season based on satellite imagery. And then the next is you look now at the indicators, which is the SPI, the WSI, and also the vegetation, and you flag areas where there are some deficit and anomalies observed, and then you also have to determine areas that is affected by these anomalies. And then lastly is to classify the type of warning. So the type of warning could be maybe water balance based, be it biomass based, be it a mix of the two, or end of the season. I think now at this session, I will hand to my colleague, Dr. Felix Rembol, to take us on these steps and explain clearly what normally actually happens on these steps. So thanks, and over to you, Dr. Felix.
Thank you very much, Oliver, and good afternoon, colleagues. It's quite a pleasure for me to be here and meet you directly. I've been working with Oliver and colleagues in EAAW for quite some time now, and it has worked very well to set up some of these systems and make available tools, and all this is hosted on the website, and I think they're doing a very good job in as being a regional center of excellence to make all this available. But it's also great to meet you, colleagues working in the countries, universities, med services. So I'm very happy with that. Thanks again, Oliver and Linda, for setting the stage. I think we move now more into the fun part with a bit of technicalities. As Oliver has said, the main thing that you see if you connect to this tool was the one in the previous slides. So agricultural drought conditions warnings, which are updated every 10 days, and they are available at the first subnational level and at the second subnational level. This is the most visible product. But behind that product, there's a lot of technical computation which goes on automatically and is updated every 10 days. And I'm quickly going through the main steps of these technical procedures behind, which we don't fully see when you look at the final result, which is the maps that Oliver has shown. So the process starts with knowing where crops and rangelands are located. There are updated crop and rangeland maps in the system, which have been produced and have been recently updated, actually this year. And also, we need to know for each little point, each pixel of these maps, we need to know, are we currently in a crop season, or are we outside the season? And if we are in a growing season, are we at the beginning of the season, around the maximum of the season, or at the end? And the system is doing this all automatically. So for each administrative region, it looks at where the crops are and the rangeland areas are, and for those areas, whether we are in a growing season or not. Then in the next step, Oliver, if you can move ahead, then it moves still works at the pixel level, and it looks at 3 agrometeo indicators. I've seen many of you are working with med offices or are working on remote sensing data. So I think you are probably familiar with many of these indicators: standardized precipitation index for 3 months, anomaly of water satisfaction requirement index, and anomaly of cumulated photosynthetic absorbed radiation. And basically, the anomalies for these 3 indicators are monitored in near real time for all the crop areas and the rangeland areas which are currently active in a growing season. And then the system detects automatically statistical anomalies, so working with standard deviations, and selects those where there is a significant anomaly. Significant, we mean really an outlier below -1 standard deviation. And then we move to the next, the system automatically moves to the next steps, where now we know where the crops are, we know whether they are in a growing stage or not, and we know whether there are anomalies of the 3 indicators we have seen, and we call those anomalies critical when they concern at least 25% of the active crop area for every 10 days, right? So as soon as there is a large anomaly for either a crop area or a rangeland area of any of the 3 indicators or of more than one, then we go to the next level, Oliver, next slide. And we basically do a classification of those agricultural drought conditions warning. And depending on how many indicators show an anomaly and what development phase we are in, we assign a color from yellow to red. So just to give you two examples, if there is a water anomaly, rainfall or water balance, only that during an early phase of the season, there would be a yellow, right? If there is an FA-PAR anomaly for 25% of the active area during maturation phase, there would be an orange. And if you have the two together, or if we have at least one in the final phase of the growing time period of the crop, then we assume there's a crop failure and we classify it as a level 4 warning. So this is really just to make you understand what's running in the background and what these colors mean. Next, Oliver. So when you look at for example, at the current 10 days period, which is the end of July, today this will be updated to the first 10 days of August, then you get this map that we have already seen. And if you zoom into that, for example, I don't know, let's look at South Kordofan, then you also see the temporal evolution of those indicators that we have named. So for example, the FA-PAR, which is a biomass indicator, and the rainfall. And you can see that they are, in this case, they are slightly below average in an early stage of the season. And we can then also look back at the 20 previous years, 23 actually, and see at this time of the growing season, which is this green part in the lower right graph, right? The gray is out of the season, and in the green, we are in the season. And then where you see yellow, orange, or red means that for those 10 days periods, there has been some kind of warning. The last 4 10 days periods are on top, and then all the previous years are below. So this information is very quickly accessible and can be downloaded and used as maps in reports or slides. And it can also be shared by using a web link. Next, Oliver. And then there's also a higher resolution environment that Oliver has already quickly shown, the high resolution viewer. And just to give an example of something relevant at the moment, I think that the colleagues from Sudan, they are aware that there has been quite strong rainfall in the later part of July and early August. There is currently flooding, including of crop areas in 3 important producing states, in Al Jazeera, in Khartoum area, and also in Kassala. In Kassala, even the parts of the town are underwater. So in the online demo, we are going to look at what this looks like and how to quickly visualize it online. Next. There has been several improvements in the latest. We're currently already at version 8 of this tool, and we moved from NDVI at 1 kilometer, which is a common biomass indicator, to FA-PAR. This is better. It has a higher resolution, and it allows us to ensure continuity in the time series from MODIS to following sensors, which would be more difficult for NDVI. Then there's, I think that the rest is already, I mentioned already, the crop masks have been renewed and revised. The phenology part has also been updated with the FA-PAR. And there is now for all areas, even in the Eastern Africa crop watch, there is level 1 and level 2 subnational data. This is important, for example, because the IPC analysis, the integrated food security phase classification, who look at this data, most of the time they use level 2 subnational. So that's an important link. Next. And yeah, and this is, so what are we working on and what comes next? We're currently working on yield forecasts. There's a collaboration with FAO JUICE, and there's a pre-operational product in the ASAP system. And we are working on including in the East Africa Agriculture Watch a national windows, which summarize the current situation at the country level. For capacity building, there have been 2 regional capacity building events already in 2024. We're currently working on the 2025 program. What is already a concrete opportunity is an event which is being organized under the EAAW project by Oliver for the countries that you can see here, and will then inform you when there are more upcoming capacity building events. All this, we are also trying to integrate this system with other existing ones. So maybe you know the GeoGlam crop monitor for early warning. There is a global and a regional one, and there are national ones. And also we are integrating the platform into the IPC digital analysis platform, which is being rolled out. Just as a summary, we think that this system can add information from the national level to the regional in various stages of monitoring, analysis, and also early action. So definitely there is a role at the national level for rangeland and cropland monitoring assessments. And then those, together with those, can contribute to regional assessments. I think those have been mentioned. And this information can then complement what is already shared or made available by all other partners, and including people in this meeting, to organizations like the Food Security and Nutrition Working Group, which is there to inform about food security and food insecurity in the region. I think this is it. There is another slide where we put some additional information and useful links, and I don't need to read that, but you can read it once this presentation will be shared with all of you. This is all from our side, and I give the floor back to the moderator.
Thank you so much, Dr. Felix and Oliver, for that wonderful presentation that you have done. We are going to take only 5 minutes so that we can have a Q&A session at this moment before we can have our online demonstration. So we are going to look at the questions that are coming up here. For example, we have Emmanuel Kumsa, who says, could you elaborate on the specific satellite data sources and sensors used for early warning in food security monitoring? How do they contribute to the accuracy of your predictions? How do you handle the integration of satellite data with ground-based observations in your early warning system? What challenges have you encountered in this integration process? Can you provide examples of how your satellite-based warning of how your satellite-based early warning system has been applied in real-world scenarios? What were the key outcomes or impact observed? What are the main limitations or potential sources of error in your satellite-based monitoring approach, and how are these addressed? How does your system account for different climatic and environmental conditions across diverse regions? Are there any specific adaptations or calibrations needed for various geographical contexts? What strategies are in place for ensuring the timeliness and reliability of the early warnings provided by your system? And finally, how frequently are your updates, or are the updates or alerts generated? Yes, back to you, to the panelists, for that question, kindly.
Okay, maybe I can give the first shot to some of the questions, and then Felix, you can handle some of them, if that is okay with you. So first of all, on the data sources, so the data sources is well documented. And I think when we go to the demo session, we will be able to show to you some all the sources of the data sets that is being used. I also want to look at some of the limitation of the system. So there are the issues of, like, for example, I can look at the case of CHAPS data. So this is the rainfall data. So the daily rainfall data performance from satellite is not really so good. And there is need to really customize this to the regional level. For example, blending with the actual data that we have in the region. So that's an ongoing process and an improvement that maybe in the long run could improve on that kind of limitation. So on the timelines of this service, so the service is mainly, and that could also respond to the issue of calibration. But now on the timelines, so this system is based on near real-time data. So there could be some delay of maybe 1 to 2 days, but it's really near real time, and even the assessment that is done monthly is mainly given timely. So I would say timeliness of the information that we are given is in near real time. So I give it back to Felix. I hope I responded to some of the questions, but I give it back to Felix maybe to respond to others. Thank you.
Thanks, Oliver. I think this clarifies a number of questions already. It is difficult to answer in 5 minutes. We wanted to answer 3 questions, and I think we got like 20 or 30, big list. What I propose is that we also collect the questions in writing, and then we can answer them more quietly afterwards, so that we make sure we leave no one out. What I would like to add to Oliver's points maybe is that some of the data sets used here are common to other systems. Oliver mentioned the chirps data, so those are important and well documented and calibrated input data. But some are specifically produced in this system. So this FAPAR time series, this is quite a new data time series, and it's available only in this system. And there's a lot of work behind that to get that calibrated and running over more than 20 years. The same applies to the crop and rangeland masks. Those have been calibrated very carefully with both very high resolution data and with field data. We have worked together with institutions like EASA and ESA to produce them and to update them. And then just also still along this question, how do you use field data? How do you calibrate? I mean, most of the qualitative information and the drought conditions warning, that is qualitative with some statistics. That is, we run one algorithm for all areas. So it's not locally calibrated and it's not crop specific. It's only for all croplands and all rangelands. However, the more quantitative data that we're working on right now, and where there's already a beta version is on the website. So the yield forecasts, for example, those are crop specific. I cannot go more into detail right now because that would go beyond our time window. But this is, I think, answers trying to answer most of the questions, as many as possible together. Back to you, Linda.
Thank you so much. Our second question is this: in areas with little to no agricultural activities, like coastal areas, are there specific thresholds or criteria used within the system to classify and manage these units effectively? Thank you.
Yes, I can give a very quick answer to this. We have excluded provinces or administrative units which have less than 1% of their area covered by agriculture. So for those areas, you won't get a agricultural drought conditions warnings, and the same applies to rangeland. So yes, there have been used some minimum thresholds, but still all the indicators which are underneath the drought conditions warnings can be visualized. So you can still do analysis for these regions, even if you don't get automatic warnings.
Okay, thank you so much, Dr. Felix. We will take the final question before we get the demonstration. The third question is: the system is highly technical and might not be well understood by non-expert organizations or individuals. So is there any effort underway to make it more usable to non-specialists?
Yes, maybe I can quickly give a response to that. So at the regional level, we have undertaken a series of capacity building events, targeting mainly what we call the intermediary people within the governments. We have our focal points from the ministries of agriculture, and also we have our staff from the agromet section of NMHS. So we've trained them as TOTs. So these are hoping that they can also extend this to other extension actors who mainly interface with the last mile user. So these are some of the things that we do, and we also take advantage of other initiatives in the region whenever it presents themselves to create awareness on this system, and also maybe improve capacity of some of the actors that at national level that we believe are, and also partner organizations that we believe are actually contributing towards the same. Thank you.
Thank you so much, Oliver. And before we just go to the online demonstration, I would like to kindly request that our participants can continue asking their questions on the chat box, and then the panelists can go ahead and answer them on the chat box so that we can save time and also make sure that we answer as many as possible. So at this moment, I will ask, I'll request Dr. Felix to give us the online demonstration. Welcome, Dr. Felix.
Okay, thank you again, Linda. So the idea here is to dedicate some minutes to look directly at the system, how it stands online. As you know, most of the time something goes wrong during online demonstrations. So I hope I ask you to be patient and ask in the chat if there's something not visible, or sometimes it takes a little bit of time to load. So if you go to the address that has been shown in the presentation, this is the landing page. Okay, so this is what you see, and it's this map that Oliver and I have shown already a couple of times now, that for the member states or the East Africa members of EAAW gives every 10 days these warnings at the first level subnational admin area, and also at the second level. So what I will do as first thing is just to switch from level 1 to level 2, and you will see the units are changing. They are smaller, and also the variability is bigger. Because why does this happen? Because if you can have basically strong anomalies in some small areas, and then of course when you aggregate them to larger areas, they're kind of average. So you can see, for example, and we look at that later, there's a warning level 3 for Malindi along the Kenyan coast. That does not show for the whole coastal Kenyan part if we aggregate to a higher level. So this is just the first information. The second is that you can also see the underlying crop and rangeland areas. With this bottom here, we play with the transparency, so we can get rid of the warning levels, and we see directly what is now in green, and those are fraction images, so they go from green to yellow. The darker green means this is the most intensive cultivation, and the no color or yellow, those are less intensive cropland areas. If we switch to rangeland, sorry, I need to get rid again of the warnings. Now you see rangeland is nearly everywhere, because this includes savanna kind of cover. It includes grasslands and includes shrublands. So there is much more rangeland, obviously, in Eastern Africa, and there are only some areas in, for example, northern, very dry parts of northern Somalia, or very dry parts of Eritrea or Sudan, where there is it's nearly desert and no rangeland. Okay, so this is just to see what we have, what are the basic layers. What I would like to show you now is that what we said is that in addition to those automatic warnings, right, that you can show for any 10 days period in the last years. So if you go back, for example, to by 1 year, yeah, in August or in last July of last year, you see that it looked different, right? We had a drought in southern Somalia, for example, and in part also of the other countries. So it was actually worse than where we are now. Also, what I wanted to show you is that you can't see only those automatic warnings, but all the underlying indicators that we looked at. So, for example, right now I'm interested in looking at the latest anomaly of the FFR, and this is interesting because there we can see most areas are blue or white, meaning that there is no problem, right? They are close to normal or they are good. But you can also see some red areas, and I can zoom in, for example, along the coast of Kenya or southern Somalia, or some areas in central Sudan and in Ethiopia. They are red, means that there is an FFR anomaly. And what we have seen is that going back to the warnings, for example, the Malindi area, if I remember well, for crops, right, has a warning of level 3, so water balance and biomass. So here I can go, that corresponds with the red colors we have seen for the FAPAR, but we can also explore that more in detail and look at statistics, right? So what do these statistics tell me? I don't want to go through all of them. We don't have the time, but very quickly you can already see that according to this graph here, nearly 50% of the active vegetation, so of the growing crops basically, are showing a poor vegetation status. And if you look at this time series graph here that shows at the same time the biomass and the rainfall, you can see that the biomass curve is nearly flat as compared to average, and the rainfall is very irregular. So the blue and the gray bars, the gray is the average and the blue is the current season. Very often they don't match. There have been dry spells during the season, and the impact of that is that the biomass is very low. If you look at the time series graphs that shows the last 20 years, the area has 2 seasons, one in the middle of the year and one from the end of the year to the beginning of the next year. We are now here, and you can see, so in July 21st decade of the year, so 21st 10 days period, you can see that the situation has deteriorated from water balance anomaly in early June to water balance and biomass now at the end of July, right? So it's quite interesting also to compare with previous years. The last 5 years, for those who are familiar with the region, are the La Nina years with three years of continuous droughts, and I think this is quite well visible here. Mostly all of the last 6, because this has 2 seasons a year, all of the last 6 crop season, with the exception of the last one, the last long short rains, had some warnings of at least orange or red during the season. So this is to show you quickly what one can do going from the map, right? With the map where you can see the warnings and the indicators. Can also visualize other indicators like 90 days rainfall anomaly that matches well with the vegetation anomaly. So that vegetation anomaly is driven by low rainfall in this area in the last 90 days. And you see that the things kind of add up to each other, so they match. While other areas of Kenya have had quite a good rainy season actually since the beginning of the long rains. Time is short and is running, so what I need to move to a last example. I want to quickly show you something completely different that you can also do with this tool. We mentioned the high resolution viewer. So we mentioned before that Sudan has experienced intensive rainfalls in the last 20 days at least. We can see this not only on medium resolution satellite imagery as we have already looked at, but we can also, so I'm now loading in real time 10 meters data. So you have seen it's enough to one click say, give me high resolution for that region. You visualize the latest available good quality Sentinel-2 data with an automatic composite that shows vegetation in red and bare soil in greenish. And these purple areas, they are actually covered by water in the latest good image. So there is very strong intensive flooding going on in Al Jazeera. These are irrigated fields, but some of this, the water is quite a lot. It's not only irrigation, it's serious flooding. And if you compare with the previous year, again, one click is enough. All these things have been loaded on the fly. This is working with Google Earth Engine in the background. You can see that in the previous year, there was no water in this area at all by that time. It came later, and it didn't come in that in such a strong form of flooding. Of course, this 10 meter can also be used really to zoom down and look at single fields, whether they are cropped or not. And in this way, one can also find out for an analyst who knows when crops are planted, it's relatively easy to understand what kind of crop this is. If it's active, if it starts, for example, right now, and it was not planted in the previous 10 days. So sorry for being a bit quick and fast, but the intention here was to just give you a view on the potential of this system and then let you speak and ask questions. So I will stop here and stop sharing and give back to the floor back to Linda and for answering questions.
Thank you so much, Dr. Felix, for that wonderful demonstration. I hope we have all looked into it, and it was a wonderful session. Now we are going into the interactive session for Q&A, and I would like to invite all our panelists kindly that you continue answering questions that have been placed at the Q&A. Some are also on the chat so that we can also make sure that we can answer as many as possible. As well as that, we'll also like to allow some of our participants to ask their questions so that they can be able to unmute and ask their questions to our panelists at this time. So I'd request like we get at least 3 participants who can be able to unmute and also ask their questions to the panelists at this moment, while the other questions can be answered by the panelists on the chat or on the Q&A session. So kindly, Pauline, I'd request that maybe if we have a participant who wants to speak and ask a question so that we can let him or her be able to unmute and ask a question. We have 15 minutes for this. The participant can raise their hand so that we can be able to identify who wants or who's ready to ask a question. You can raise hands as well. Thank you.
Okay. Hello. Good afternoon.
Good afternoon, Ezra.
Okay. I hope you can hear me well.
Yes, we can. Go ahead.
Okay. I had a question on how we are going to delineate one specific crop in monitoring just a specific crop. For example, if we are only dealing with a certain crop, maybe, for example, maize and not other crops like coffee and from other vegetation features. So how are we going to separate that using the normal satellite imagery in the monitoring the same? Thank you.
Okay, thank you, Ezra, for that question. I would request one of our panelists to answer.
Yeah,
Ezra,
I can give a
kindly.
quick reply. Ezra, thank you. A very good question. In fact, this is a common need, I guess, by analysts. The moment the way the tool is organized, you can get automatic warnings only for all crops together. Of course, in some regions that makes sense because there is a dominating crop. So if you have sorghum or maize making up 80% of the crop area, then you're happy with that. But I agree with you. You can't go down to very specific crops like coffee or others. At the moment, the only way you have there is to do that would be to go to the high resolution viewer. There you can edit, you can basically digitize a group of fields, and then you can extract NDVI curves from high resolution imagery just for that group of fields, so that you make sure you zoom down to what you're actually interested in. But the warning information and also the statistics on the website, we are not able to go to single crops. Also, I mean, you are perfectly aware crops are changing every year. So to do that, basically, you would need to have dynamic crop masks updated every year. That is quite a challenging process, and there are not many countries in the world where they're currently able to produce dynamic crop maps in an early stage of the season for every year. Back to you.
Thank you so much, Dr. Felix, for that, and I hope Ezra has gotten that answered as well. So we can also get a second person who would like to ask a question. We can get a second person. You can kindly raise your hand. If you want to ask a question, you can raise your hand. You can as well also put your question on Q&A. So if there is no one raising their hand, then we can go to the Q&A and at least try and answer some of the questions from there. There is a question here from Mohammed Abdirahman. He says, what's the easiest way to track and follow up these warnings? And then we have another one, Simon Peter Okello, who says, how frequent? Please try to quantify the frequency. So we can also have one of our panelists to answer some of those questions. Thank you.
Maybe I can give a thought on that. So first of all, on the easiest way to track these warnings is just by going to our system. So our system is freely available. We've shared the link, and I think it's also from the demo that we have seen. You can easily track and see maybe areas of concern for your particular locality or your country. So that's number one. The other question is on, Linda, what is the other question? Oh, okay, I think the other one was on frequency. So the frequency of these warnings is on 10 days. So the warnings is given every 10 days, and this is done automatically by the system. And it's by just going to our system, you will be able to see for your area of interest. Thank you.
Okay. Thank you. There's another question here. How does the system distinguish between different causes of crop stress, such as drought versus pest infestation? And what measures are in place to minimize the uncertainties in predictions that could lead to false alarms? Additionally, what types of ground validation methods are used to verify the accuracy of products?
Maybe I can answer some of these. All very good questions. So it's quite an interesting discussion. Thank you for that. I think for damages different from drought, as those you mentioned, like insects or diseases, that's quite difficult. Most of the time, we cannot really go at this level of detail with the resolution we have. We even did quite intensive work on for example, on the desert locust impact some years ago. And we realized that even with the 10 meters resolution, the impact on vegetation of desert locust was quite difficult to trace, because those, as you know, those swarms, they're it's quite random where they not only where they sit and where they land, but also how much they eat and in their different development stages. So that is still quite challenging. Most of the impact you will see from these warnings is due to either drought, flood, or late start of the season. So when you see a strong warning in a semi-arid area, 90% of the times it's either drought, floods if they're very large in space and time, or a strong delay of the season. But also because, for example, delay of the season, that is flagged very strongly, and sometimes the season can still improve. So you might call that a false alarm, but in that case, we prefer to give a bit of stronger warning at the beginning of the season if we see a strong delay, because we think that because there's a high risk that when a season becomes shorter, that it leads to lower yields. We might overemphasize that warning a little bit in the logic of providing early warnings for food security. But I would argue you can contradict me if you find strong problems of misclassification or false warning. Please come back to me, because I don't think we have major problems of this kind. I mean, the system is now operational already for 6 years, and in most cases, when we see a strong anomaly or a strong warning, then there is either a drought or a flood or seasonal delay. Back to you.
Okay, maybe, thank you so much, Dr. Felix. Oh, yes, Oliver.
Yeah, maybe to just add one point from what Felix said. So this system should not be used in isolation. So this system responds to maybe a particular challenge in the region, but there are other challenges also affecting the crops and rangelands. Like, for example, I think there are a lot of people who have talked about how the system incorporates the issue of pests. So there are pest warning systems that are being developed by ICPAC and I think other institutions. And I think this, once it's ready, it should be also used together with such a system to give a holistic kind of advisory on information about the system. Thank you.
Thank you so much, Oliver. There's this question here: how secure and flexible is the system to the end users Or is there any capacity building or training apart from online one?
Maybe I can start and then Oliver comes in. I mean, the online is for sure one of the main ways of providing training and assistance, but we also regularly participate in on-site trainings. There have been already 2 organized in the region this year, one by EAAW directly and one by GEOGLAM. So we don't have resources for providing on-site training following up on all requests, but normally we try to combine with major events or with partners who are specifically funding capacity building. So this is our approach.
Okay, so also to add is that as Felix said, so on-site training, so in-person trainings is really limited, and we have only managed to train a few people in the region, mainly focal points, with the hope that they can also cascade this to the other staff within the ministries. But aside from that, I think if you go to the system that just Felix talked about, there is an online demo on how you can use the system. So there are some resources that we share that you can have a look at it before you get the training. At least you can have an idea of what is happening, because as we said, these trainings are not a bit limited, especially the in-person one.
Okay, thank you, Mr. Oliver. Another question, is there a possibility of identifying meteorological drought in a system?
Yeah, good question. I would say this is really optimized for agricultural drought. So we look at, we try to look specifically at crop and rangeland vegetation. If you are really interested in meteorological drought in terms of water only, I think some of the indicators might be of interest to you, like for example, the 3 months SPI, but that you can also get from other sources. Probably the water satisfaction index that is unique to this system. That is something that you might consider of interest also for meteorological drought. Of course, it's already going in the direction of agriculture. But depends a bit on what your application is. And also something that other questions reminded me. I mean, one of the added value of the approach of these tools is that basically you don't need to download any of the indicators, because everything can be accessed in a very quick way online, and you can do basic operations and visualization and mapping with the indicators and with the warnings online without needing to download. So it's a significant improvement in terms of time as compared with previous approaches, where you need to download the original image and then do GIS operations to overlay your shapefile and to extract data for your region. This is all ready to visualize and to use. So it's really an improvement also in time, and that I hope that was visible in the online demo.
Maybe to add one point. So there is also responding to the meteorological drought. So there is also other watches that we have at EAAW. So we have the East African Drought Watch. So you can actually go to the East African Drought Watch, and also, which is a system just like the Agriculture Watch. So you can visit that system and also get information on meteorological drought. Thank you.
Thank you so much. There is another question here. How and who can contribute to developing national capacities and use of the information, including move from recommended policies to action on the ground?
Felix, yes, do you want to try that?
Yeah, I can start. I'm not sure I'm the best place, because I'm not being in the region. I probably don't know all the resources that you have available, all the organizations and their exact mandate and the resources they have for organizing capacity building. On our side, the Joint Research Center is part of the European Commission, so we try to work as much as possible together in the EU to understand how to prioritize capacity building, how to fund it, and how to work with partners like FAO, WFP, or even other countries, FuseNet and others. So we usually try to coordinate as much as possible, so that especially with regional capacity building, we cover the different as many tools as possible. But I'm not fully aware about all the partners and the resources available in the region. I think EAAW there is much better placed.
Yeah, so for the Eastern Africa, so definitely we use different platforms for capacity building, but the main contact in the national level for issues to do with agriculture is the ministries of agriculture. So that's our first point of where we train, even for the focal points that I said we train from the ministries. But this is not only limited to the ministries of agriculture. So we also extend the same training whenever we have an opportunity to do this at the even subnational level, where we can train extension actors there and other partners contributing to the overall agriculture and food security space. All those actors. So that would be the ideal. It's not limited. The training is not limited to anyone, but our contact point would be the Ministry of Agriculture for that matter at country level. Thank you.
Okay, thank you so much, Mr. Oliver. We also have another question here. How do you manage to use the satellite to monitor specific crops so that you can get the exact crop? For example, if you are dealing with coffee or maize, how are you going to separate that from other vegetation?
Yeah, I think we answered this already, but let me come back to it because it's probably was not fully clear. The problem with that is that you need crop type maps, right? You first need to know what crop is grown where, and that changes every year. So it's quite a challenge to know exactly what crop is grown on each field. There are projects trying to do this. Specifically, we are involved in a project called Copernicus for GeoGlam, where we produce crop type maps for different years, for different countries. We have worked in Kenya, Tanzania, Uganda over the last years, and I know that other large organizations, like for example NASA Harvest, but also the Australians, also they run programs to do crop type mapping in various countries in Africa. So I mean, if you want to go more deeply into knowing exactly what crop is grown where, then you need to use such a detailed crop type map first. But the problem is that they're not available everywhere at all times. And with this system, we're trying to provide something which is comparable over time and space. You can go back 20 years and compare situation of 20 years ago with the current season. For that area, the crop might have changed. So it's very difficult to be at the same time very specific spatially, but also to keep comparability. That's why at this time, we don't go really into crop type specific. And we think it's more important to give an early warning information at an admin area level without being able to say this is mainly maize or this is mainly millet, but we in being precise at when an anomaly happens and when there is an alarm. Then the idea is also that this information is then shared and used by experts on the field. And if you are an expert if this is sent to Linda for Taita Taveta, she knows probably much better than me what crops are active right now in that area. And so she might even know better than me whether this warning is more relevant for maize or sorghum or other crops, right? So this is a bit the approach.
Okay, thank you so much, Mr. Felix. I think as we wind up, so we have one question here from Simon Peter. What is the criteria for developing the classes? Because I'm trying to understand the last three classes would not leave out most of the small scales agriculturalists, majorly in areas where like 90% concentrate in cattle and not crops. So we can have that final answered.
It's not very clear, unfortunately, this question, but I would just say if you have 90% in cattle, then we definitely focus first on rangeland vegetation. Yeah, and that signal is clearly there. As we said before, for crops, you need to have at least 1% of the administrative area covered by crops, and then there will be a warning for those crops. If it's less than 1%, definitely it's not automatically available, and you need to work with other imagery with a higher resolution.
And also, Felix, I think he wanted to know about the the classes of warning for the rangeland and also for the cropland. So for that case, if level 1 warning, which we normally call water balance warning, is triggered when when the indicator, the SPI or WSI is actually critical, and we say in the critical, the anomaly is less than -1 standard deviation, and it covers more than 25% of the active area. So that would be for the warning level class number 1 on water balance. The number 2 is on biomass warning, and you look at the vegetation. So if the anomaly also FEPA, if it goes beyond -1, the anomaly is -1 standard deviation, and it also meets the area, the critical area fraction, then it triggers the level 2, and then level 3 is a mix of 1 and 2, and then goes to the last one. So it's well documented actually in the presentation that will be shared with you shortly. So maybe you can have a look at that. I see there is one question, Felix, maybe that we need to address. I see one from Jim Hansen, I think it's from IRI. How do we integrate the system with seasonal forecast, and for that matter, EAAW seasonal forecast? So I just wanted to say that this has been done at the global level with the multimodal forecast from EU. But the integrating with EAAW forecast is work in progress, and maybe hopefully we are going to do something similar to what has been. I think in our last presentation there is a paper that we developed on that, so maybe you can have a look on that. Thank you.
Okay, thank you so much, Mr. Oliver. Thank you so much, Dr. Felix, for that wonderful session. I think that at this moment we are just winding up because our time is gone. I want to say thank you so much for this discussion and this, because so much that we have learned today for each of us, including those of us who are in charge of this department. We have seen that there is the importance of going digital, the importance of data, the importance of having this automatic warning in terms of improving our agricultural activities and even livestock, in terms of actually getting the drought warnings, all the indicators to enable us as East Africa that has been impacted by climate change and extreme weather conditions, that this kind of system will be able to identify and get early warnings that will be able to help us in critical decision when it comes to mitigation measures. These are also this is also a system that, when well used, it can be able to help us in various departments in terms of early warning, so early actions, and also getting additional data to various departments like livestock, agriculture, and other departments. Also, it helps countries, especially in East Africa or African Atlantic, to monitor the situation in terms of food security, and to make sure that all the countries are food secure, and not just food security, but also the nutrition. But some things have also come up during this workshop, especially when it comes to technicality of the system. And I think this is a takeaway for all of us, that for those who are more knowledgeable in terms of the system, that you can be able to make sure that those that are at the ground level are able to access this, and also able to read and get the data and to get the early warnings. That is not only going to be used at the national level, but our national so at the target, they are the farmers and they are also the livestock keepers. So I think moving forward, these are our takeaways in this work, and I think more trainings are also needed. Like most of the participants talked about it, that we have to look into ways whereby this knowledge or this system reaches as many people as possible, not just at the top, but even at the level. So I'd really take this opportunity to give you, to thank our panelists, our wonderful panelists, for the wonderful job they have done with the nation, and also the demonstration of the system. I hope that we have all learned something that is relevant to our department and that we can actually use so that we can be able to tackle the food insecurity in our region and also to boost food production. So thank you once again for those who have participated, those who have engaged in various ways, answering questions on the chat and even speaking to us. So I actually express my appreciation to the speakers and all the panelists for their valuable contribution. Also, my deepest gratitude goes to all of you who attended this webinar and helped it to make it successful. I hope that throughout the day, we have been able to develop a discussion that will help us to achieve all the things that we are doing in our various departments to make sure that we achieve one common goal, which is having a food secure continent. And I would also have to remind you that all the presentations will be shared to you, all the participants, and also the recording of the webinar will be available on our YouTube channel. So you can go to our YouTube channel and get the recording so that you cannot miss anything that was discussed in this webinar. Finally, at this moment, I would like to announce the GHACOF 68, which will be happening next week on 19th to 20th August. The registration link will be shared to you on the chat, and also on the website, you'll be able to get the registration link so that you can register in advance so that you can be able to attend the GHACOF 68, which will be happening once again, I'll repeat, on 19th to 20th. That will be next week. So I'll take this opportunity to say thank you to all and have a lovely evening.
Thank you too, Linda, for the moderation. Very good. Thank you.
Thank you and goodbye.
Thank you.